So to look at normalization from a positive standpoint rather than a negative way, it's best summarized as the rules of one. Let me explain. If you take one type of items or one group of things, they should all be together inside of one table. Each one item should be represented in the table by one row or one tuple. Each one descriptive fact or one attribute about those items should be represented in one attribute or one column in the database. And then every one of those columns should actually describe that specific entity, not some other entity. If you follow these three rules of one, meaning one type of item, one entity, one item, one tuple, one fact, one attribute, you will always be normalized. Some key terms used throughout database modeling: the primary table and the secondary table. Think of these two tables as the parent-child table if you're relating multiple tables together. The primary table will always have the primary key. The secondary table is the one with a foreign key. In a few moments, I'm going to show you several patterns using the primary and secondary tables. Three other key terms. One is cardinality, which means how many objects can exist on each side of that relationship. For example, is it one-to-one, one-to-many? Cardinality is usually described as either 0, 1, or many. 0, 1, or infinity. Then there's optionality, which determines whether or not that relationship is mandatory or optional, which is actually designed inside the database as whether or not the foreign key allows nulls. Then there's referential integrity. Referential integrity, or RI, is often thought of as no orphans, meaning if there's a row in the secondary table with a foreign key, there has to be a row matching it with a primary key. That's close but not exactly correct because of optionality. A better way to state referential integrity would be that if there is a value in the foreign key, there has to be a matching value in the primary key. To make this very practical, a couple examples of referential integrity would be that if there's a paycheck, there has to be an employee for that paycheck to match up to. Or if there's an order detail row, there has to be an order header row with a matching order ID. Inside SQL Server, referential integrity can be enforced by DRI, meaning declarative referential integrity, simply by building a foreign key constraint. If declarative referential integrity or a standard foreign key constraint can't handle the complexity of your needs for a certain specific case, you can always enforce referential integrity by building a custom trigger. And when we get to the triggers lesson, I'll show you how to do that.